Hey guys, Roman here. Today we're here with Mark Brown, a guru on the Kodiak 100. He was the what's your background, Mark? I don't want to butcher it.
Yeah. So I worked for the manufacturer as the head of sales for Factory Direct, head of marketing, and the chief demo pilot for 10 years. And I've got 7,500 hours, give or take, in the Kodiak 100 and 900.
Awesome. So we're taking a business trip to Knoxville, Tennessee, to the CBRNE conference, and we're going to pre-flight this plane, get it ready to take up, and we're going to get there in 4.5 hours, hopefully. So we'll see. All right. So Mark, cool. Take us through the plane and let us know how to pre-flight the plane.
Yeah, so all Kodiaks are similar in a lot of ways, but there are some differences. So this is essentially a brand new one. It's a 2023 Series 3. And so this is kind of the latest and the greatest. We're here in 2023. You just took delivery of this a month or two ago.
A few months ago, yeah.
And so it's kind of got all the latest features. So this airplane has the 4-bladed Hartzell propeller, and so essentially a pre-flight will just start from the tip, work our way to the tail, and then go around the other side. Mm-hmm. On the propeller, we're looking really mostly for any blade damage. Of course, This is essentially a brand new plane, but you just want to run your hand down the leading edge of the blade, and if you see any nicks or anything like that, that's cause for concern sometimes, depending on the size of the nick. And then in these boots, these are actually this is where the TKS fluid for your anti-icing. So there's little channels here, and it helps the TKS fluid run down the leading edge of the propeller to prevent ice buildup on the propeller. So that's really what we're checking here on all 4 blades. And these are metal blades, so this is kind of what you want for the backcountry as well. So this is a good prop for this airplane. And then in the inlet here, again, this is really just more visual, so we're checking to make sure this is in the open position so we can see fully down in there. And we're looking to make sure there's no rocks, grass, anything that bird nests for it sitting in the hangar. Sometimes birds like to live in here because after you shut down, it's warm. So we're just, again, looking there, and then we work our way down to the nose wheel and the strut. This is a pretty good... you want generally about 2 fingers here. Anything less than 2 fingers, you need a little bit more nitrogen in the nose strut generally. Wheel.
And that would be a no-fly situation, no-go.
Generally, right? Yeah. If this is, especially if it's all the way compressed, you definitely, you could damage the strut, so that would be a no-go. And then sometimes if you have a lot of weight in the back of the plane, this actually you can end up seeing twice or almost triple this. And so if it's fully out, that's also not necessarily abnormal. You can actually pull, you can see here, if I pull on the prop, I can pull that back down. So when people get in and out of the back, it's normal for that to kind of decompress a little bit. So we don't care really how much is showing as long as you have about an inch or so of that metal showing. Nose wheel in general, you're just looking tire tread, make sure it's inflated, looking at the hub, making sure that there's no grease or anything coming out of the wheel hub. But really it's mostly just visual. Moving back on this side, this is our air intake for the oil cooler and fuel heat exchanger. So again, just making sure no birds, anything that got in there while the airplane was sitting. Moving back here to the engine compartment. Put this up. So a couple things in here we're looking for. Generally just a kind of a general glance. Making sure, again, there's no oil splatter everywhere. There's no dirt. There's nothing that looks out of the ordinary. Again, mostly just visual. I check our 5606. This is our brake fluid. It's really the only red fluid in the whole airplane. So if you see red dripping anywhere from the back tires or anything like that, it's the brake fluid. Up here we have the AC compressor. Again, I kind of touch a lot of things to make sure nothing's loose. And then behind the AC compressor, you can't really see it, but there's a clutch back here that should be able to be turned just with your fingers. Can you see that?
Yeah, I can see it.
That black clutch.
That's the clutch, okay.
Yeah.
So that works similar to a car clutch?
Generally, yeah. When the AC, when the environmentals tells the AC it needs to come on, that engages and it turns this belt. The belt is driven off the accessory gearbox. And then the next real thing up here on a pre-flight to check is the oil. So this oil dipstick, we'll bring it out. And so right now it's between 3 and 2. That's totally normal. So in a Dash 34, this is different than a piston engine. This reads the top 4 quarts of the oil tank. So this reads quarts low. It doesn't read like a car reads how many quarts you actually have in the tank. This is a 13 quart tank, and this only reads the top 4. So even if it's all the way down here at 4, you still have 9 quarts in the tank. So as long as it's on this dipstick, we're good. Of course, if it gets down here at 4, we'd usually add a quart.
Where's the ideal place for it?
Right where it is.
Right where it is.
Yeah. The thing to remember with this oil tank in this engine is it's a pressurized tank. So you can see there's kind of an over center lock on that. You just always want to, if you're going to check the oil, you always want to make sure that the oil cap is put back on properly.
Right, otherwise it can go spewing while you're turning on the engine, and
Exactly.
that's a problem.
It's a big problem, yeah. So then just a few other things for your own kind of knowing what you're looking at here. This is your alternator. That's kind of for essentially our standby electrical system. So if we had, and then up here, top dead center is your starter generator, that gold thing, and that's a 300 amp starter gen. That's your main source of electrical power. It produces 300 amps, way more than the airplane needs, frankly. But if that fails for any reason, this alternator runs the essential bus, so it runs the things that you need to get safely back on the ground in the event of a generator failure. Nothing really to look at there, just knowing what it is. So if something does look abnormal, when you call your mechanic, you can kind of properly describe, oh, I'm looking at the generator. And then this gold box here is your MCU. Essentially, that's a master control unit. That's kind of the computers that talks between the avionics and the engine. So those are your, and then this is your one battery over here, and then you have another one on the other side. Again, not really anything to look at there, just knowing what it is. And then I usually look kind of just down here, again, making sure that there's no, egregious oil leaks or anything like that. It's a brand new plane, so it kind of needs to get, a couple hours under it. You're going to have some little leaks here and there. That's not abnormal. It's just kind of getting everything lubricated. So we just want to make sure that there's no oil puddling or anything like that. So that's what we're looking for in the engine.
So you said egregious. If it's light, then it's all right? Or like, how does that work?
It's you kind of get a feel for it. You're obviously brand new to this plane.
Yeah.
So generally speaking, turbines, PT6s, all have a little bit of oil that will leak specifically out the breather tube onto the belly. And so the breather tube is this gold tube down here. So if you see oil on the belly after flight, not abnormal. A tiny little bit of oil dropping here and then getting in the airflow looks like a ton of oil on your belly when it's really just a drop or two. So again, totally normal. Not all the seals are perfect. There's little areas, and it's obviously a very high pressure engine. So, it's going to push oil out anywhere it can find an escape route. So a little bit of leaking, your oil is not always, you're going to have to add a quart here and there. And that, when you add a quart, you've lost a quart somewhere, and that's just going to kind of be in different parts of the engine.
And that's something the operator can do on their own,
Yes,
right? Okay.
Yeah. You can add, as the pilot, not mechanic, you can add a quart of oil. Generally, I'll write it down in the flight logs just to know when I added it and kind of see. And that's another telltale sign of, like, if you're adding a quart every 10 hours, then you probably have an oil leak that's bigger than normal. That's kind of there. This is your GPU, your external battery. Power. So if you ever had like a low battery, the airplane was cold soaked, you left it outside for a couple days and the battery wasn't quite 24 volts, you could start this with a GPU. You just plug in a GPU here.
Is that like a jump start kind of feature as well? Or
Yeah. A lot of bigger airplanes actually require a GPU to start. Just because the draw of the engines when they start is such that no battery could handle it. This airplane starts just fine on the batteries, but if it's if the batteries are a little bit low because they're cold or older, getting weak, a GPU start can be done. But yeah, essentially just a jump start. This is just an inspection area for the front bay of the car, or for the forward front of the cargo pod. So this is no storage in here, but again, if the airplane sits outside or on the ramp for a couple days, like in Knoxville, if it's not in a hangar, for instance, we might want to check that again, just to make sure that nobody's messed with the plane, put something in there, things like that. Moving back, cargo pod, really not a lot to check in here. It's your airplane, so you're generally going to know what you have in the pod. If I fly an airplane that I haven't flown in a while, I always look at the pod and know how much weight is being stored, because a lot of people just leave heavy stuff in here all the time. But up here, this is your TKS tank. So our TKS is our fluid for anti-icing. We won't need that today, but in the event that it was cold out and we have to bust through a cloud layer today, we might run in, or there might be an icing air vent out there. In that case, we would need what's called minimum dispatch. So to be legal to fly into ice, we have to have, right here, you can see this line that says minimum dispatch, and you see this little red floater. We would need to have at least that. That's 9 gallons. And so
if you have the system, then you have to abide by the law of having minimum dispatch in icing conditions.
Correct.
Got it.
Yeah.
Okay.
So technically, the airplane is not FEKI certified if you're below 9 gallons.
Got it. Okay.
And we have obviously plenty. And the avionics will tell us as well how much exactly we have, but this is just a visual check.
Okay.
And then for the rest of the cargo pod, just making sure that everything's closed. These are real easy to tell. If they look like little wings, then they're closed. And then kind of coming up to the wing here. So you have single point on this, which is super nice.
So previous models didn't have single point?
Not as standard. This didn't become standard until 2023. So I just like to, number one, I like to check. The big thing with the single point system, you have to remember, is it always needs to be off. So you can, if you turn this up, this is hot, this is running off the battery right now. And if you leave this on, or the line staff leaves this on, it will drain your battery. Not a good thing. So one thing that I always make sure, if I'm not personally supervising the fueling, I make sure the line guys turn it off when they're done fueling, because some of them will leave it on. But anyway, we can see here we have 600 and 600, so 1,200-ish pounds, so we'll want to fill that up. If we're going to go direct, we'll need full fuel today. But that's how the single point works, and then off is the middle, and then this is just a quick display of the quantity if you push down.
So what's the difference between on and quick display? Why would you want to use one or the other?
On is how you actually fill it.
Oh,
quick display is just for you and I, if I just want to do a quick fuel check.
So in order to fill it, you got to turn it on.
Correct. Yeah.
And what are the other buttons there?
Yeah, so the way to work it essentially is so it stays off. The line staff will come, they will hook up the single point, they'll hook up the ground, and then they'll hook up the single point. And then they turn the SPR system on. And on the truck, they'll actually start fueling. And then once they start fueling, and this is, because this does a left self-check, a right self-check, essentially the computer in this doesn't allow for the truck or the operator to over-pressurize or over-fuel the airplane, so it has kind of a little control computer in it. But once they turn it on, they pressurize the system, then you open the left and the right, and then it starts fueling from there. And then if generally the left wing fuels a little quicker than the right, just because that's got less distance to flow, you can shut the higher tank off to fill the lower tank. So if you wanted, like say we wanted 800 pounds a side and the left wing got to 800 pounds quicker, we can just turn the left off and continue filling the right. And then when they're done fueling, they turn these left and right off, and they turn this one off, and then they disconnect.
And you could turn it off mid-fueling. While they're fueling, you could turn one side off, and then it's just going to reroute it automatically.
Yeah, they don't need to stop fueling.
Okay, got it.
Yep. So on pre-flight, if I got fuel, I'm always checking this. Number one, to make sure that they turned it off, but also just to verify the amount of fuel that I have.
Got it.
All right, coming back further on the wing, really nothing to check on the strut. This is just make sure that, again, nothing's hit it. Leading edge of the wing, again, just a visual check. This is your stall vane here, so that's your stall angle of attack vane. So that's just a little flipper switch. I'm not that tall, but yeah, so pretty sensitive. Again, leading edge, make sure that there's no damage, anything like this. This is your pitot static system. So you have one of these on both sides. So obviously your pitot mast here, but then you have your little static holes also right on the bottom there. Again, making sure that there's, the cover's off, there's no, bees or anything that have made a nest in there. In this part of Texas, I've had mud daubers make nests in less than an hour in my pitot tubes before. So it does happen. Lights, really, again, just making sure that they're there. If you did like a real pre-flight, if you went by the checklist, we would have turned our master on, and then we would actually turn these lights on just to make sure they're all operational. Since we know they are, we don't really need to do that right now. But if you really wanted to check, like if you were doing like a night flight, it'd probably be a smart thing to just go ahead and turn the master on, turn all the lights on, and just do a quick walk around to make sure all the lights are operational.
Cool.
Back here, let me I like to just check, since it's a brand new plane, especially after these come out from paint. I'll just turn the ailerons so I can see all of the different bolts. And so what I'm looking for, there's 3 connection points. It's kind of hard to see with the backlight, but there's 2 here that's pretty easy to see. And then there's 1 up here on the top. And what you're looking for, there's a little highlighter orange, it's called torque seal, on the bolt in here.
Yeah.
And that just says, what that torque seal shows us visually is if the bolt has started to unwind itself. And so essentially what that torque seal does is the bolt is here, that torque seal goes from the bolt to the nut, or from the nut to the bolt. And if it unwinds that torque seal, there'll be 1 here and 1 here, and you can tell visually.
Yeah, I see that. It's on the same thing, so.
Right. And they're also cotter pinned as well, so it's very unlikely they ever move. But again, that's just good pre-flight practice to check those.
What's this hole here?
That's your, good catch. So that's your fuel vent. You have 1 on either side. You definitely want to make sure that's not clogged. If that's clogged, you'll cavitate your fuel. Essentially, that's how when you burn fuel, the air that refills the tank comes up through that. And if that's clogged, you'll create a vacuum in the tank. And I've actually seen wings cavitate on themselves because they've created a vacuum because that was clogged.
And that's once again like a bee can get in there and do something, or
So the one that I saw was overseas. The airplane was sitting outside for less than a day. And the way that fuel vent is, it goes up about 2 inches and then makes a 90-degree turn. And at that 90-degree turn, he had a total mud dauber nest in there that he couldn't see really that well. Had he actually looked up in it, he probably could have seen it. But from where you and I are standing, it wasn't visible.
So it's something that's good to look in with a flashlight, maybe, just to kind of look in there.
Exactly, especially if the airplane's been sitting outside. And so he took off, and the left wing tank couldn't vent, and when he landed, it actually had almost crinkled up on itself. It had vacuumed. Everyone was fine. The plane ended up getting fixed and is still flying today, but it was an expensive oops.
Yeah.
So yeah, you definitely want to check that, especially if the plane's been sitting outside. Next thing I'm going to do, if you just want to stand here, I'll bring the flaps all the way to 35 just so you can gauge, number one, how long they take, and also just kind of what that looks like visually. Sure. So really big flaps, one motor. I would say if there's a weak point to the Kodiak, it's the flap system. And the reason for that is it's just, again, it's all electric, and they're massive flaps, right? You can see these take up more than half the wing and they're huge. This is 35 degrees, right? So when you're flying, there's a lot of air pressure getting pushed up on these, and then when they come down, it has to fight that air pressure. So it's not insignificant the amount of force that motor has to overcome. And with flaps this big, there's something called flap asymmetry that's a real big problem for if airplanes ever have asymmetrical flaps. It's a massive issue, and it's almost uncontrollable in most airplanes. And so what this airplane has is what's called an asymmetry sensor. If the sensor inside the computer system senses that one flap is going faster than the other, it fails the flaps and it says, do not move anymore, because it would rather the flaps fail than to have them come out asymmetrically. And so there's a lot of very sensitive kind of fail safes on these flap systems. So it's usually not that big of a deal. You'll get it's what's called a flap fail annunciator. You can just reset the circuit breaker, reset it, and usually it goes back to normal. And the newer the airplane, generally the less of an issue it is. But in my 10 plus years experience, is probably the most common failure that I see on Kodiaks is that flap fail. So I just like people to see just how big they are, how long they take, because it's not, on smaller airplanes, especially airplanes with mechanical flaps with like a Johnson bar, you can pull the flaps out, you can dump them really quickly, where these, it's like when you have flaps, getting rid of the flaps, say on landing, is not going to help you land shorter or anything like that. They take too long. So every takeoff in a Kodiak is with 20 degrees of flaps. Most landings are 35. There are, in our training, we'll do some no flap landings. We'll do some 20-degree landings. Like I'll usually do if I'm flying a instrument approach. Generally, I'll land with 20 degrees of flaps because I'm going into a bigger airport. I don't really need that last notch. But most landings are full flaps, 35 degrees. A few things to look for on pre-flight. So in here, you can kind of see these are all, this is a roller area up here as well. Some people I've seen put like a wet grease on those areas, thinking that it needs grease to roll more freely. That's a no-no, because these are open to the elements. So even just landing on tarmac, like there's dirt and grass, and when that engine starts, it'll kick it all up. Well, if you have a wet grease on these flap tracks, that dirt's going to go right and stick in that wet grease, and it'll actually make things worse. So you always want to make sure that these look dry. Like they'll sometimes use a dry grease. That's fine. I leave that up to the mechanics. But what I'm looking for as a pilot is just to make sure that these, nobody's put a wet grease in there. And then back here, what we're looking for again is just these accordion covers. That's just a cover. Again, just making sure that's not rubbing or torn. There's nothing, living up here. Wires are all good. You have another one of these accordion covers here.
Now to do this, you have to turn on the master here, right?
I did, yeah. So
the master is, which one is the master?
The left one, the red one here.
Okay, so that's the only button you had to put on. Right?
Correct, yep.
Okay, you did it, and then you turned it off right away after you saw that the lights were good.
Yep.
Just to save the battery.
Yep,
Okay.
yep, exactly. The flaps have a little bit of play in them, not a ton, but they're not like super solid, and this is a normal amount of play. That's all normal. And then working down here to the tire, solid state gear. So beneath this cowling here, there's essentially a trunnion. So your gear works like this, right? So if my fingertips are your wheels, my thumbs are the carry through tubes. So essentially it's all solid state. When you're on the ground, you're kind of pushed out like this, and then when you take off, it kind of comes up like this, so that these middle solid, or the carry through tubes flex slightly, and then here is just a straight tapering tube, so it's like a 3-inch to a 2-inch tapering tube here. And so why that's great is there's no shocks, there's no springs, there's no hydraulics. Really, from a maintenance simplicity and reliability standpoint, there's really nothing to break in the landing gear system. But it does generally have a little bit of, on the ground it rides a little rougher. It's more like a F-250 as opposed to a Land Rover, just because there is no shock absorption, essentially. And then what we're looking for on pre-flight is just the brake system. Again, if you're going to have a red brake fluid, the 5606, if it's going to leak, it's probably going to leak somewhere in this caliper system. So generally, if the airplane has been sitting for a night or two, I just kind of look right here on the ground, make sure that there's nothing red. You will often see a little puddle right here, but it's TKS fluid. So TKS fluid, when you use it, it's a viscous glycol. It's a weird consistency, but it's very viscous. And so the idea here is it has to weep through these little holes. So it does not stop weeping the minute you turn it off. It actually will weep for a couple days thereafter. And it'll form at the low points of the line. So right here, you'll have a puddle right there, and generally you'll have a little puddle right there. If you're out, like say you're in Knoxville and the line guys, we show up tomorrow morning to fly this back, and the line guys say, hey, your brakes are leaking. Generally, it's just TKS fluid that's leaked.
And that's why they made it red, I guess, so you can differentiate between TKS and brake fluid.
Right. Okay. And if they're mixed, it'll be pink. So if it's a pinkish fluid or a red fluid, then it does have some brake fluid in it. If it's just a clear viscous, then it's just TKS. And then really the tire, again, just looking at the treads, this is a brand new tire. You'll have plenty of life out of this. But these are lower pressure. Normal PSI is 30, plus or minus 3. When this is fully loaded, they look flat compared to most airplane tires. So again, a lot of people might come up to you and say, hey, do you want to check your tire pressure? It looks a little low. And again, you as a pilot can check your tire pressure. It's, just like a car, you just take this out and check it. But you definitely want to, these tires being lower pressure tires, they will lose air pressure over time, especially in cold weather. So it's not abnormal. Like on some of the Kodiaks that I manage, I'll, once a month, I usually check tire pressures because you don't want to be flying this with them below, 27. They're already a low pressure. So that's kind of what I'm looking for here. Back here, inside, we'll kind of get to in a minute, but really there's not a lot inside that we need to do from an airworthiness standpoint. Like you can have the seats in or out. The big thing is just making sure the seats are locked in the seat tracks. Of course, these seats, to move them around, you just lift up on these two and the seat will move.
It can move forward and back or be removed.
Or be removed, okay. Yeah. The only thing you have to do when you do move the seats around is account for that in your weight and balance. So if you take them out, generally the most Kodiaks when they come from the factory are weighed with the seats in. So if you remove the seats, you actually reduce the weight of the plane, but we can look in the POH and see actually how they did it. I prefer the airplanes generally to be weighed without the seats, and then I add the weight of the seats because I'm usually not flying with all 6 seats in the back always. But these are really cool seats. These actually can be turned fore or aft, and so you could fly with these all forward facing. You could turn them all around rear facing. It doesn't matter. These seats are certified to go both directions. So like when people get in from, and I'll just kind of demonstrate this, I'll get in here. So if you ever have passengers close the door from the back, this is something I see often. The way to do it is you just pull up here. The one thing you want to remember is these are gravity stairs. There's no mechanics to these, so we'll just take this out. And then when they go to open the door later,
it falls.
It falls.
It breaks something.
So the way, these are just supposed to be stowed flush like that. So if you're closing the door from the inside especially, you just make sure that's done. And then to close the bottom clamshell, you just push that. And then on the top, this is a kind of an interesting thing. So this door, when you close it from the inside, a lot of people will pull this and then close it. Well, if you see what happens on the outside, this is stayed up. Well, you don't want to be flying around with that up.
Yeah.
So the right way to do it is when you go to close it from the inside, you don't pull out, you just take your finger and push. And now you'll see that it has closed all the way, and then you have your latches, your 3 latches. When you open it from the inside, you want to pull out and then up. And the reason it's like this is because all airplanes have to be able to you have to be able to egress even if the outside is locked. So like you could lock all 3 of these doors and I could still from the inside get out of them all. It doesn't matter if the door is locked or not. I can still egress from the plane. So that's kind of why it's funny like that. But just something to remember. And then when you open these, you just want to, let them down because again, there's no hydraulics or anything to let them down. So
the 900 has hydraulics, right?
It does. Yeah. That's why you're paying $500,000 more.
The other guy who showed me the plane, he just like kept advertising the 900 to me the whole time. I was like, is this like a sales pitch from Kodiak to get me to buy something else? Yeah. You're really like obviously dissatisfied with this plane that you're teaching me to fly here. So.
Yeah.
Right.
But these are, I mean, again, I like the 100 for me I've flown the 900 a lot. It's an awesome plane for like the right clientele, but like it does not do the backcountry. You can't put it on floats. Like for me personally, the 100 is the way to go.
Yeah.
Because I like to do the backcountry stuff. I like to load it full of dirt bikes and go land on a gravel bar in South Texas and have some fun,
Absolutely. That's why I got the plane.
Exactly.
What sold me is on the website, the catchphrase is the ultimate escape machine or something like that, the ultimate escape vehicle. And I was like, sold.
That's what I want. Yeah.
I'm gonna buy that.
Sweet. That's.
Is that you? Did you come up with that phrase?
Me and my team did.
Okay, cool.
Yeah. So, I appreciate it.
You got me.
Yeah. So then on going further back, really not a whole lot here. Again, just visually checking, make sure everything is, no dents, no dings, no animals living. These are just strakes. These come with the cargo pod. You can always look kind of from the back straight on. Of course, these should be straight. If you ever see these like canted up, I've seen these before where people like hit them with a tug or something in the hangar. So again, just visually check and make sure they're straight.
So if this is not straight, then that's a no-fly situation?
Yeah, it means it means some, what generally when it looks sort of bad from the outside, it could be worse in places you can't see, right? So like if this was bent, potentially you could have bending or issues with the actual like frame and longerons in the fuselage. Because this is a pretty big moment arm. And so if somebody hits this, it can drive that in, and now you've got frame damage.
So let's say there is damage to something like this. Would you then have this plane towed to the nearest facility, or how do you get it to the
Good question.
repair place, right?
So usually it depends. I always defer. I always have a mechanic come out here. They look at it. They do an assessment. And a mechanic can apply for what's called a ferry permit. They can essentially say, hey, we know that this is damaged, but we have assessed it and we believe that it can be safely flown from this airport to the closest service center, which is located here. And the FAA will give you approval, and you can only do that flight. There's other things like it's essential crew only. You can't bring passengers on it, things like that. But that's usually how.
I guess that's the same as not getting your annual, right?
Correct.
If you don't have your annual in time, you get a ferry permit.
Ferry permit.
Okay, got it.
Yeah, exactly right. So, not all damage prevents the plane from being airworthy to get to a service center. It just usually, if there is damage, you need a mechanic to assess it and say, yeah, this is safe to fly to a service center.
What are these vents?
Yeah, so this is just essentially rear. So your tail cone starts right here. So this is what's called your aft bulkhead. And so all of this is your tail cone. There's a lot in this tail cone. You have your oxygen bottle. You have your aft AC evaporator. You have your aft air mixing box, which is called a plenum. So all that needs to breathe, essentially. And that's what this is for, is there's one on each side. It allows the tail cone to breathe, essentially. And then this one, you asked about this. This is just a visual, so you can see inside this tail cone to what you're looking for in here is this kind of all this bolt system where everything comes together. Again, just checking, make sure it's all, you got torque seal, there's...
Yeah. And they made it a lighter color to make it more defined, kind of?
Yeah, generally, yeah.
Okay, got it.
And then out here, again, on your horizontal, really just looking leading edge. Again, I always look in here. So again, birds love these areas. This actually, there's some covers you can put on here, but they're...
I have the covers.
Yeah, I saw that. But if you sit out, the covers for this particular area, frankly, they kind of blow away in the wind. So I don't always use them, but I always do double check here. And anytime you're like putting your hand in here, always hold this, because if the wind catches this and your hand's here, that doesn't feel very good. Just speaking from experience. But anyway, and then I always, again, I'm not that tall, but I can at least reach the elevator. I can't reach the ailerons, but you just want to make sure that this is moving freely. There's no catching, nothing like that. These are your static wicks. You can have one of these missing per flight control surface. So, and these just unscrew. So I've seen like idiot teenagers at airports like unscrew these off of planes before, just because they think they're funny. These come into play really, this is if you're ever flying close to a storm, you'll know if you don't have your static wicks, because you'll get what's called St. Elmo's fire. It's like a lightning coming up the windscreen. It's cool looking, but it's quite frightening.
Lightning coming up the windscreen.
Yeah, well, I'll show you some videos. It's really common in jets, like, because they fly higher and faster, so they build up more static electricity. But yeah, even in a Kodiak, like if you're flying close to a storm and you don't have static wicks, the plane does funny.
The static.
Yeah, it does funny things. So you have 2 on each aileron, you have 2 on both sides of the elevator, and then you have 4 on that. And you can have 1 missing per flight control.
Okay.
Yeah. Trim tab, again, this is pretty normal. That's kind of what it's supposed to feel like. And now you can see that torque seal a little bit better there. And I always just look here, again, I'm looking at bolts everywhere that this is connected, up in here, again into here. The other thing too I'll show is this rudder and elevator are pretty close. It's kind of hard for you to see probably, but
Yeah.
I've also seen hanger rash on the bottom of these.
So you don't want to put this fully up and then move this.
No, you can. I just like to show how close it is, right? So that goes fully up.
Oh, okay. Yeah. So it's almost hitting, right?
Yeah, probably like an inch clearance. But the reason I point that out is, again, I've seen hanger rash where people have like hit their head or caused this to be slightly, or like even a rock I've seen come up and hit this. Just I always like to make sure that it's straight, because in the event that it is bent up or you have some damage here, that's why we do the pre-flight, is just to make sure that every time we walk around it, after your 100th time, you'll be like, okay, yep, that's normal. And anything abnormal will catch your eye pretty quick. Quick on the tail stand usage. My rule of thumb on a Kodiak 100 is anytime the rear door or the aft cargo door is open, I have the tail stand on. I always have this on if the rear cargo door is open, if I have other people I'm flying with. If you're just taking the airplane up and going flying, don't worry about it. But like in the case, there's 3 of us here today, if you put a bunch of camera equipment in the back and you were standing in the cockpit and I didn't know it and I just went and hopped on that cargo door, there's a potential that it could weight shift and then fall on its tail. Essentially all airplanes are just teeter-totters, right? And on the front end, you have the nose wheel, which prevents you from going down, but on the back end, you have nothing. And even, there was just a California the other day, like a FedEx airplane fell on its tail. If you load any airplane wrong, it's not just Kodiaks, you can get them to fall on the tail. Just the Kodiak is unique in the sense that our main passenger entry and exit is in the back. Most airplanes, it's up in the front. So usually when you have people get in and out, they load the front to the back. In our case, we load back to front. Well, if everybody is loading or unloading at the same time, that's when you get the issue where the airplanes fall on the tail. So I find it to be most prevalent after landing. So say you're flying with your family or your friends or buddies and you've got a couple dirt bikes or whatever, and you shut down, what does everybody do when the airplane stops? They all migrate to the door they came in. Well, in our case, that's all to the back. So what I usually do as a pilot is I say, hey, everyone, just shut down. Everyone just stay seated. I'll hop out. I'll grab the tail stand from that aft cargo compartment, put it on. Then I open the door and then say, okay, now everyone can come out. That's just, again, a quick thing that'll prevent, again, and if this falls, I've seen them fall before where there's like next to no damage, just some cosmetic damage, but I've also seen them fall where the ground's not perfectly level and one of these hits first and it pushes this whole thing into the fuselage, and now you've got to essentially rebuild this whole aft tail cone. Again, no fun. Yeah. So just kind of showing you things where I've seen and learned from my experience. Again, in the back here, I just lift this up, make sure I'm looking at all the bolts. Kind of exact same thing on this side. Just making sure free movement, you're not hearing any clinks or clunks or anything like that.
And I guess the purpose of this horn right here is for aerodynamics, right?
Yeah.
Where this, if you need to put this up, then it assists you with the other thing coming down, the other side, the horn, I guess.
Yeah.
Okay.
Yeah, and it's also for like tail blanking, like if you get a lot of weird aerodynamics with the propeller and the prop wash coming around the plane, but like if you're and most things you see on airplanes are because of the edges of the envelope, right? Like when you actually need this aerodynamically, you're in a weird situation. Like you've put yourself it's really more on a test pilot side that we're testing stuff like this. But yeah, like if the top of the tail, like your real high angle of attack and the top of the elevator and horizontal aren't getting any airflow, this is still getting some airflow, which can prevent you from having, loss of elevator authority and stuff and some weird phases of flight. So that's exactly right. Up here on your dorsal, you have this antenna as your ELT antenna. And then right behind that is called your NACA duct, your dorsal NACA duct. That is your fresh air intake for your aft cabin. So like when in the summertime, when you're hot and you have all the vents open, all the air, the outside air going in is going through that duct. And then right here is your AC evaporator. And this is, so essentially it's like a square box right about here, or right about here. And this is your AC and the Kodiak. You have a forward evaporator and a rear evaporator. And in both, so you have AC throughout the entire cabin. The heating is only in the front in the 100. So all the heating comes from the front to the back, but AC is, you have forward and backwards. So the AC system on this is pretty phenomenal, frankly. Over here, really a lot of the same. Won't go through all the same things again. A couple of the differences here is this is your fuel drain access. Some people know this is like sumping. So essentially what this is when you have a cargo pod, there are 6 fuel drains on the belly of the plane. If you were to sump these, you just pull this out, take this little cap off, and then turn each one of these, and this is how you sump the fuel from the belly.
So as a sump bed, just testing the fuel, right? To look
correct.
at it. Make sure there's no fluid in it and some water.
It's not, frankly speaking, it's not that common to sump jet fuel as often as you sump avgas. Like avgas, you generally are sumping it every time you take fuel. Jet fuel, not so much. In fact, a lot of the jets I used to fly, like on a 135, we had it in our SOPs that the pilots were not even allowed to sump the airplanes. It was only a mechanic function. So not something, if you're getting fuel from, a reputable fuel farm, the FBOs have to test every morning anyway. So not that you want to rely wholeheartedly on them, but...
is there a shelf life on jet fuel?
There is. I don't remember what it is, though.
So, but if I don't fly my plane for like a few months, is that okay? Or is it like a year not okay? Do you know?
Yeah, so one of the things that I do in my business is I manage customers' Kodiaks, and that's one of the big things that will do, so you have a brand new plane. So technically speaking, this airplane needs to fly every 30 days to maintain things like your engine warranties on certain components. So it's less about the shelf life of the fuel and more about airplanes that fly regularly don't have issues. If you have things sit, then you have oil sitting and pooling, and that's when corrosion can pop up, things like that. So for like a lot of my clients, they only fly, I have a lot of float planes, right? And so we only fly them in the summertime, and they sit all wintertime. And so in the winter, me or somebody from my team will go fly that airplane for at least an hour every 30 days, kind of run through all the systems, make sure it's still operational. So that is something that you'll want to do. And if you can't, then you can, call me or somebody can come down and fly it.
Absolutely.
Over here, really, same wing stuff. Won't go through all that. The only big difference here is the weather radar. Really nothing you're checking here per se, except just visually. This is an onboard weather radar. It's a Garmin GWX 75. All that means is pretty cool.
Yeah.
Weather radar, cool functionality. Being here in Texas in the summertime, this is going to be really useful because you can pick your way through those pop-up storms in the summer. But yeah, just visual check, make sure there's no damage to it. And then kind of the last thing, again, this is like a very in-depth pre-flight. You won't do this every flight, but or it'll go a lot quicker, I should say. On this side, we've got a few things. This is your right-hand battery. Underneath this, where this line goes, is to your fuel filter. So all the fuel from the tank to the engine goes through the fuel filter. There is a bypass function. So essentially, if the filter is clogged, the fuel will still go to the engine. It will just bypass the fuel filter. And there's a physical switch. If you kind of get your head down, you can kind of see where my finger is here. I don't know if you can see down there.
Yeah, I see that little red button in there.
But that'll pop up, and that'll be
it's that red button down there. Over here. Oof.
You kind of have to get it from,
Okay, so that what does that physical switch do?
It tells you if the fuel filter is being bypassed.
Okay,
so if that's popped up, it means
that's not popped up right now.
No, that's flush.
That's flush, even though it has a little give. Okay.
Yeah. So if that's popped up, it means you've got bad fuel, and that would also be a no-go item.
Yeah. And that's something you probably want to do every pre-flight, is to check that.
Yeah, and I also always tell people, if you forgot or if you didn't, whatever, on your Garmin avionics, that's also an annunciator. So if your fuel filter is being bypassed, it will say, I forget exactly what the annunciator says, but it tells you, your fuel filter is clogged or whatever. But yeah, I generally I like to look at the engine compartment any flight I do, just to, especially this side, because you can really see where, it's a lot more visibility. And so I'll just put my hand down there and make sure that's good. A few other things just to know what you're looking at here. So this air intake here has three different, this is your main one, this is your fresh air into the cabin. So it goes through this kind of mixing box muffler here into the cabin through the firewall. This is also your bleed air muffler. So this big insulated line comes from the engine. This is the hot extra bleed air from the engine. It mixes with the outside air, goes in, and then behind the avionics essentially is a air mixing box internally as well, and that's what controls your heat, cool air onto the pilots. But that's, this is a nice feature. This wasn't on all Kodiaks. It used to be bleed air essentially directly into the cabin, and it's very loud.
Oh, is it?
Yeah. So this muffler was a big improvement over the years. And then up here, this is your compressor wash. So you'll sometimes hear, if you have somebody that, if you're flying, say like in Florida, we do a trip to the Bahamas or something, usually anything salt is bad for metal, right? And even the salty air around the ocean is bad for the engine because we're essentially flying through it. We're picking up all those salt minerals that are up in the air. And what you want to do after a couple days flying around the Bahamas is you want to do a compressor wash. And you just essentially, they make a thing where you take that out and you hook another thing to it. And you essentially just motor your engine and put, some people will just use regular water. You're supposed to use a low mineral content water just so you don't have minerals sitting in your engine. But that just gets all that salt out of your engine.
Like some kind of distilled water or something.
Yeah, yeah. So like on the float planes that I fly a lot, we do that after every single flight. So every single day after we've landed on salt water, we do a full aircraft wash.
And is there like a special machine to do that? Like you just like plug it in? And
it depends. Not on some of our airplanes, we just use hose water. We just get a hose extension, and then we have a fitting at the end of our hose that goes right into that. It's a really actually easy thing to do. Your engine actually has to be cooled down a little bit because you can't shock cool it. But once the engine's cooled down, you just connect it, turn the water on, you motor the engine, and the engine essentially motors over for a couple seconds. You shut it off, take the hose off, let it kind of dry out for a sec, and then you actually will turn it on. You'll start the engine, and the heat will then evaporate the remaining water that's in there. So that's what that is. Back here, I'm sure in training you probably learned a little bit about the FCU. So that's essentially this metal silver mechanical thing. In the Kodiak, we have what's called an emergency power lever. The EPL is fuel direct to the engine, and we use that in the event of an FCU failure. So this kind of mechanism right here is a real complex mechanical mechanism, and our throttle is connected to that. And then that regulates the fuel that goes into the engine. It's very precise. Like our throttle movement, we can set to the 10 on the torque. So, 1210, 1220, 12 is super precise. But this is, of all things on a PT6, it's the most mechanically complex, you could say. And if anything were to fail, that would be more likely to fail than like the engine itself. And so if that fails, your engine is still totally operational. Your throttle just doesn't work. And so that's why we have that EPL as our backup. And we can bypass that FCU and go fuel direct to the engine.
What's the EPL again?
It's called the emergency power lever. I'll show it to you in flight as well. But those are a couple of things on this side that again, and then just from a general pre-flight, making sure there's no oil puddling or anything loose or hanging.
It's still pretty clean in there. So.
It still looks
You
good.
have a dead bug in there, though. I see him.
He's
sitting there. Looks like he's been there for a while.
And then I'll show you this to drain the fuel filter. It's kind of the last thing on this side that we'll do.
Another thing, never touch this, right? Because the fingerprints will never come out.
Yeah. Well, your fingerprints will be on there. You might not have fingerprints.
The pilot that American Kodiak hired, that was one of the first things he did when he was taking the plane over.
Really?
As he was explaining the plane, he touched it. We're like, don't touch it. He's like, oh.
What was his name?
Kyle. It's all good, Kyle. I forgive you.
Yeah. Down here is your fuel filter drain. So in order to do that, if you just hold that, you just lift up on this yellow tube. Watch your shoes here; it'll come down. But essentially, you just lift up right there, and that drains your fuel filter.
Gotcha.
They say drain daily. I'm more of a practicalist. I don't.
If you don't drain it, then it just leaks out itself, right?
Yeah, well then that's not this. If you don't drain this, it'll just...
It's the EPA catch can that you have to drain, right?
Correct, yeah, and I'll show you where that is. It's on the other side. So you got that GATS jar, that kind of jar that's about this size. Yeah. Right next to your oil breather tube right here, that's what you push up, and that drains into that GATS jar. And so a lot of turbines just route that into the exhaust and it burns off. In the Kodiak, we didn't do that. We actually have a catch jar. After about 4 to 5 shutdowns, that will be full. And all it's doing, essentially, when you shut the airplane down, there's some unburned fuel oil mixture in the engine still, and so that's just drains into that can. Well, if you don't drain it every single flight, after about 4 to 5, it'll be full. And if it's full, the next shutdown, it'll just dump it on the ground, the whatever is overflowing. I don't really have a issue with that generally. I mean, was born and raised in Texas. We grow the stuff here. It's just going back where it came from.
Yeah.
But in some corners of the country, they don't like that. So it kind of just depends on where you're flying.
Got it. Okay. Makes sense. What's this?
That's just essentially a very long cotter pin. So it's connecting this bolt to that bolt just so they don't come undone.
Okay, got it.
And it's just got, normally it wouldn't have this sheathing over it, but I guess they do that just for...
To protect the metal
to
underneath.
protect it, yeah.
Got it. So you can't really unscrew it because that depends on this. They're like,
Yeah, you would, if you wanted to unscrew this, you would actually have to cut this pin, or the wire, the
got it. Just another safety mechanism, basically.
Right,
Okay.
yeah. Pretty much all bolt, this is not actually a cotter pin, it's safety wire. I used the wrong word. This is a cotter pin.
Yeah.
So you can see here, like, you actually physically can't undo this without first cutting this pin.
Yeah.
And that just prevents this bolt from coming undone in flight. And then safety wire does the same thing. It goes through here, and they can then connect it here. And the way that it's kind of an art when you go to mechanic school. There's some guys that they get really particular on how you safety wire stuff, but it has to be real tight curls. But what it does is, the way this is set up is this doesn't allow this bolt to loosen or that bolt to loosen, because that safety wire is essentially always in tension.
Yeah.
Very long pre-flight.
All right. Well, thank you for showing us the pre-flight.
Yeah.
We're going to continue on inside, guys, so follow along. Yeah, so why 330?
Yeah, so in a Kodiak, generally, we burn about 330 pounds per hour, so 330 pounds or 48 gallons is an hour's reserve fuel. So I always, at minimum, my personal minimums is I'm always landing with at least 330 pounds of fuel in the plane, and essentially
And you can
hour's
dictate this
reserve.
based on your personal minimum.
Well, kind of, yeah. I mean, the FAA states that in a VFR flight, we always have to land with 30 minutes reserve. IFR, it's 45 reserve. I bump that up a little bit and say I always want to land with an hour reserve fuel. So there are FAA mandated minimums. My personal minimums are higher than they're mandated. I like to always land with an hour of fuel left. And then for the rest of the weight and balance, so pilot, how much do you weigh?
220.
So just type in 220, I'm 160.
So as you reconfigure the layout here, let's say chairs, no chairs, you can reconfigure these slots?
Not really.
Like, let's say there's, no?
No.
Okay.
So this is set, I mean, technically you can. There is a calibration that you can do. It's a little bit beyond what I would do like as a pilot. I would use like the Kodiak Performance app if I was doing that. And that's where we need to go in here and figure out, and then we can do it in flight because I want to be cognizant of your time as well. I want you to get there before dinner, but this is essentially, think about this as kind of fixed. And then if you do recalibrate, you kind of just do some mental math, right? So, but this is for just demonstration purposes. I'm going to say we have 50 pounds in that bay, we have 50 pounds in the middle bay, we have maybe 30 pounds in the rear. Cargo zone in the plane, we probably have, let's call that 50. And then TKS, we have about 13 gallons, so call that about 120 pounds. And so now you can see here, we have, we're within the confines, so we're well within weight and balance. You can see here our ramp weight is, for takeoff, is 6715. Our takeoff weight is 66.
So that's our weight right now versus...
versus the less. So during taxi, we're going to burn 50 pounds, so we will be 50 pounds less on takeoff. And you can see...
I don't like that number. Shit, man, that's ominous.
Yeah, right. But anyway, so we have 7255, so we could theoretically have like 400, a little over, 500, 500 more pounds of weight that we could carry in today's configuration.
500 more?
Yeah.
Okay.
So like...
two extra people.
Two extra people, some gear, 500 pounds more fuel. We currently have enough fuel to go essentially 3 hours. Circuit breakers are all in. All these are back. Flaps can really be wherever, it doesn't matter. They can be up, they can be down, they can be at 20, it really doesn't matter. These are all back. All ice is off. Lights, so these are ice is on the bottom, lights is on the top, lights as needed. And then I'm over at my starting gauges. So now, so of course this is master and avionics already on. I'm just pulling this back so I can see. So then we're gonna do the auxiliary fuel pump to on. So it's a 3-position switch. That one. Yep. Ignition on.
Hold it or no? Okay, on, just on.
No, just on. And then the starting switch here is spring-loaded. We always use low, so we're gonna hold that down.
Down.
And
hold it down.
Just hold it down. It's spring-loaded, so we hold that through the whole start sequence. And what we're looking for here is, we're looking at NG percentage and ITT. So if you start, go ahead and push it down. If you see this, our NG starts to come up. At above 15, I can add fuel. Keep holding that. Now you'll start to see there's a light off. So ITT, we're monitoring this, that it doesn't go into the yellow. Also monitoring the NG. So there was peak at about 7:30. NG is above 52, now we can let it go. So that's as easy as the start is. You hold that starter the whole sequence, 15%, add fuel, monitor ITT, 52%, let go. Engine started. After start, it looks like when I say the C flow, C is like in Charlie, it looks like the letter C. So we release the starter, turn the igniters off.
Ignition off.
Yep. Fuel pump to standby. Auxiliary bus on, the big white switch. Generator alternator on. It has like a long tail to it, so then I come over here, lights and ice as necessary. So if we were on anything but pavement, I would go ahead now and go into bypass. We don't need to do that because we're on pavement. I might turn our taxi lights on because we're about to taxi. Then I come over here, prop to max RPM, so just bring it all the way up to where it naturally stops. So right there is good. And then flaps to 20, so they already are. Now our environmentals are on, so we can actually turn that on now. One thing to note, so we'll see if this will do it. I'll turn the AC on. You should see a little thing here that says air conditioning inhibit. It may not come on right away. But the AC needs 58% NG in order to work on the ground. So I'm going to turn that off. But what I do to get that, I bump this up to right about 58, 59. And now I can turn the AC on and it'll work on the ground.
58%, which is right there.
Yeah. So that's your after start checklist.
Okay.
We
Cool.
do headsets now.